Let's dive straight into the most crucial skill for survival and health. Making water safe to drink, starting with the most reliable method known as heat pasteurization. When you think of making water safe, you probably picture a pot bubbling over a campfire. That's boiling, and it's incredibly effective. Bringing water to a rolling boil. I'm talking big, vigorous bubbles, not just tiny simmers. At 100 degrees Celsius or 212 Fahrenheit, will annihilate virtually any bacteria, virus, or protozoa that could make you sick. For total certainty, keep that rolling boil going for at least 1 full minute. But there's a catch. Maintaining that intense heat consumes a massive amount of fuel, a resource that might be precious. This is where a smarter technique comes in: heat pasteurization. You only need to heat the water to 65 degrees Celsius or 149 Fahrenheit and hold it there for about 6 minutes to kill the vast majority of dangerous pathogens. But how do you know you've hit that exact temperature without a thermometer? You use a clever little tool called a water pasteurization indicator, or WAPI. It's a simple tube with a special wax inside that melts precisely at that 65-degree mark. When the wax drops, your water is safe. No wasted fuel, no guesswork. Now, before you even think about heating your water, there's a critical preparatory step: pre-filtering. Imagine you've collected water from a stream. It's full of silt, leaves, and other floating bits. Trying to sterilize this murky soup directly is inefficient and sometimes ineffective. So, you need to remove that sediment first. The method is incredibly simple. Just pour the water through a piece of clean cloth. A bandana, a t-shirt, even a dense sock will do in a pinch. Into a cleaner container. You'll see the fabric catch all the larger gunk, instantly clarifying the water. It's a satisfying process. But be absolutely clear on this: filtering through a cloth only removes visible debris. It does not remove the microscopic threats. The water might look clean, but it's still teeming with invisible bacteria and viruses. This step is about preparing the water, making it ready for the real purification that follows, ensuring that no pathogen can hide behind a piece of grit. From fabric, let's turn to the most powerful sterilizer in our solar system: the sun itself. This method is called solar disinfection, or SODIS. It's a brilliantly simple and cost-free technique that uses the sun's ultraviolet rays to neutralize pathogens. Here's how it works. You take clear, transparent PET plastic bottles, the kind most soft drinks come in. Make sure they aren't heavily scratched or colored. You fill them with your pre-filtered, clear water and seal them tightly. Then, lay the bottles on their side in direct, bright sunlight. To boost the effect, place them on a reflective surface, like a piece of corrugated metal roofing. The combination of the sun's UVA radiation and the increased temperature inside the bottle work together to destroy microorganisms. The rule of thumb is to leave them out for at least 6 hours on a clear, sunny day. If it's partly cloudy, you'll want to leave them for 2 full days to be safe. The key again is that the water must be clear to begin with. Turbidity acts like a shield, protecting the microbes from the sun's sterilizing rays. But what if you don't have 6 hours of sunlight? What if you need safe water right now? Technology has harnessed that same UV power into a portable, pocket-sized device. I'm talking about UV light pens, like the popular SteriPen. These gadgets are a hiker's best friend. You simply take your clear water, switch on the pen until a blue light glows, and stir it in the water. The pen emits powerful UVC light, which is a specific wavelength that scrambles the DNA and RNA of bacteria, viruses, and protozoa. By destroying their genetic code, it makes it impossible for them to reproduce and cause illness. The whole process takes only about 90 seconds for a liter of water. It's fast, efficient, and leaves no chemical taste. However, they are not without their limitations. They require batteries, so you always need to have spares or a way to recharge them. And just like with SODIS, their effectiveness plummets in murky water, as any suspended particles can cast microscopic shadows, protecting pathogens from the UV light. While technology and heat are effective, nature itself provides raw materials that can clean water if you know how to layer them correctly. This brings us to the biofilter construction, utilizing sand, charcoal, and crushed gravel found in your immediate environment to mimic the Earth's natural cleaning process. Imagine an empty plastic bottle, flipped upside down with its base cut away, serving as your filtration vessel. At the very bottom, where the cap would be, you'll place a plug of cotton or a piece of cloth. This initial layer is crucial. It acts as a final barrier, preventing your filter media from escaping with the clean water. Above that, you'll add your most powerful purifying agent, a layer of crushed charcoal. Be sure to use pure wood charcoal, not commercial briquettes which can contain chemical binders that would contaminate your water. This charcoal layer is an expert at adsorption, pulling impurities, odors, and strange tastes from the water. Next, pour in a thick layer of fine sand. The tiny gaps between the grains will trap smaller, suspended particles that the other layers might miss. Finally, top it all off with a layer of coarse gravel. This is your first line of defense, catching leaves, twigs, and larger sediment before they can clog the finer layers below. As you pour questionable water in the top, it percolates slowly downward, each layer stripping away contaminants until cleaner water drips from the bottom. Remember, this isn't a one-and-done solution. The mechanical parts, like any sponges or cloth, should be cleaned every 2 to 4 weeks to prevent bacterial growth and maintain flow. From a constructed filter, we move to a remarkable solution provided directly by nature, the Xylem Filter. This method harnesses the intricate internal plumbing of a tree branch. You'll need to find a small branch from a non-flowering tree. Gymnosperms like pine or cedar work exceptionally well. Carefully peel away the outer bark to expose the pale sapwood underneath. This segment of wood is then fitted snugly into a tube. As water passes through the length of the branch, it's forced through the xylem, the microscopic network of pores that transports sap throughout the tree. These pores are so minuscule they effectively trap pathogens. In fact, research has shown this simple stick of wood can remove over 99% of E. coli bacteria. However, this natural marvel comes with critical warnings. You must be certain of your tree identification. Never use wood from toxic trees like those from the yew family, as poisons can leach into your water. Practicality is also a consideration. The filtration process is incredibly slow, yielding about 1 drop per minute, making it suitable for personal survival, but not for purifying large quantities. Now, let's shift to a method that relies not on physical filtration, but on chemical warfare against microbes. Chemical purification, most commonly with household bleach, is a fast and effective way to disinfect water. The key is precision. For clear water, you need only 2 drops of standard, unscented bleach per liter. After adding the drops, stir the water well to ensure the chlorine distributes evenly. Then let it stand for at least 30 minutes. This waiting period is non-negotiable. It's the time the active ingredient, sodium hypochlorite, needs to neutralize harmful microorganisms. But this method comes with serious safety protocols. Using too much can cause nausea and abdominal pain. And you must never mix bleach with other chemicals, especially ammonia, which creates toxic chloramine gas. It's also vital to understand its limitations. While bleach is effective against many bacteria and viruses, it does not remove chemical pollutants, heavy metals, or certain hardy protozoan parasites like Cryptosporidium, which can cause severe gastrointestinal illness. Our final technique is the most passive, a clever trick that lets plants do the work for you, the transpiration bag. Find a healthy leafy branch on a non-toxic tree that gets plenty of sunlight. Take a clear plastic bag and carefully place it over the branch, enclosing a good number of leaves. Cinch the opening of the bag tightly around the branch with a cord, creating an airtight seal. Now you just wait. Through the natural process of transpiration, the plant releases water vapor from its leaves. Inside the sealed environment of the bag, this pure water vapor has nowhere to go. It will condense on the inner surface of the plastic, forming droplets of clean, drinkable water. You can then collect this by tilting the bag to let the water pool in a corner. Under optimal sunny conditions, a single bag can yield between half a liter to 700 milliliters of water in a day. It's essentially a solar still powered by biology. While the yield isn't massive, setting up multiple bags can provide a reliable source of distilled, exceptionally pure water in a survival scenario. Mastering these diverse filtration methods ensures that no matter where you are, you can turn a questionable water source into a life-sustaining resource.